I want to take the opportunity to acknowledge the traditional owners of the lands where I'm zooming from, the Ngunnawal people. The traditional nations of Australia have innovated and adapted for 40,000 years, and the 21st century is no different. Around our beautiful country, traditional owners are using drones for lands ranging. They're using drones for mapping and for monitoring, for STEM outreach and for inspiration, and for digital excellence to contemporize their dreaming stories. I acknowledge and am inspired by these efforts. The emerging traditional owners continue their history of innovation and adaptation. So here's some context setters. And if you didn't know, that's cool. But but I want everybody to know a couple of context setters for this talk. And I think the first one there is that it's big already. UAS. The Army is Australia's biggest, most experienced, safest drone user. There's more than 1,000 drones, more than 1,000 operators out there, and they're used in specialised, non-specialised, and for sport. So the full spectrum of use of uncrewed technologies. Our Navy has been experimenting for quite a few years now and are well and truly established in their own UAS squadron. And our Air Force is experiencing and establishing their capabilities right now. So, we have flown Heron in the past. We have people embedded in the US and in the UK doing that experiential learning that they need to help establish our squadrons in the upcoming years. And by the mid-20s, the Australian Defence Force will be a very unmanned, uncrewed force. There will literally be drones everywhere in ADF operations. And I think that is really exciting. And it's the start of uncrewed expansion, which will exceed $30 billion worth of expenditure by the 2030s in our integrated investment plan. So what? It means that this is science fact. It's certainly not fiction. The Australian Defence Force has been quite good in embracing the technology. We are a world leader in UAS technology development. We've got some amazing industry here in Australia and some amazing thought leaders. And the Australian Defence Force is a world leader in some aspects of UAS as well, Army in particular. What I'm going to do is go from the biggest down to the smallest to tell you about what's happening in the Australian Defence Force. The title of the presentation is out to 2040 because that's how far our integrated investment plan and our force structure plan go. And that is the core of the roadmap forward for where we're going with UAS into the future. So some of the slides I'm going to go through are reasonably old in a UAS sense. When I get to the Shadow 200 in Army, it's already a decade old. But some of these platforms that I'm going to talk about are right at the leading edge of what they're doing in technology and are about to come into service. So I'll start at the biggest. Our biggest airplane project at the moment is under Project Air 7001 Bravo. It's to acquire the MQ-4C Triton. And that's a cooperative program with the United States Navy. Looks a lot like a Global Hawk and that you might have seen anywhere in Global Hawk imagery over the last 20 years, but it's not a Global Hawk. It really is the very most modern iteration of the Global Hawk. And when you lay them down side by side at a schematic and a subsystem view, they're actually very, very different airplanes. And that is truly exciting for us because this airplane's contribution to maritime patrol and response, that's what MPR stands for, is going to be significant. A main operating base out of Tyndall in the Northern Territory means very good access to our northwestern and northeastern approaches. And the amount of ocean that this airplane senses is able to hoover up on a 24-hour mission is simply incredible. And the way we intend on employing it with the P8s, with the MC-55, with the Royal Australian Navy will be quite game-changing for the way that we monitor our air-sea approaches. It's about $2 billion worth of expenditure coming down the pipe, and at the moment we're on contract for 3 air vehicles at the moment, with an initial operating capability in 25, 26-ish, but with the airplanes still only just starting their time on the production line, there's still some flexibility in exactly what dates we'll see that. I said it will be flown out of Tyndall, but a really interesting evolution of this kind of technology is how much of these airplanes are contributed to in satellite communications for command and control. And that sees us able to do launch and recovery out of Tyndall, but for our main operating base to be RAF Edinburgh for command and control of the aeroplanes. And that's for a really good reason. We wanted to create an ISR precinct in the Royal Australian Air Force, a node where we can maximize the efficiency of our satellite bearers, our ICT networks, our processing, exploitation, dissemination of our multiple platforms that are all contributing to the intelligence, surveillance, and reconnaissance effects that the Australian Air Force delivers for the ADF. So that's Triton in a nutshell. It's still a couple of years away, but I can tell you it's a very exciting project and some amazing capabilities in its avionics and sensor bays that will be truly game-changing for how we monitor our northwest and northeast approaches in particular. Next one down, Air 7003. Project Air 7003 is acquiring the MQ-9B Sky Guardian. Looks kind of like what you'd seen for the last 20 years in the MQ-9A Reaper and the Predator series of aeroplanes. But once again, a very, very different aeroplane, despite its external looks. This aircraft is being built to provide persistent ISR and electronic warfare and precision strike to the land force. That's its mission statement. So it's an air platform purposely acquired and flown in support of Australia's land and special forces. So a squadron of these being based out of RAF Edinburgh. And when I say that it's different, it's armed and it's certified. It's certified to be armed, certified to be flown anywhere in Australia. Well, certifiable. We obviously haven't undertaken the certification activity to get it certified yet, but built to a certifiable set of aviation standards. Again, it's about $2 billion worth of acquisition. We'll see 12 aircraft, so a full squadron worth of aircraft operated and based out of Edinburgh, but able to globally deploy anywhere, certainly within the Australian, domestic and near region, but able to be deployed overseas as well if that is government's role for this airplane. A very impressive array of weaponry and very impressive capabilities in its intelligence, surveillance, reconnaissance, and electronic warfare capabilities. This photo uses about half of its pylon attachment points to show to give a visual indication of some of the way that we could load it out, but it's actually got 9 attachment points along those wings and center line of the fuselage. Inside that big nose is a synthetic aperture radar capability as well, with ground moving target indicator capabilities and maritime modes as well, and inverse SAR modes. So a very, very capable aeroplane. And I've included there a photo of what will be the ground control station cockpit of this remote piloted aircraft system. Still a couple of years away, just like Triton. But working with our US and our UK partners, we're already on that pathway. We have people embedded in the Royal Air Force Operating Squadron that's going to be the first customer for the aeroplane. And we've got personnel embedded in the acquisition and engineering teams in both the UK and the US. So a very exciting program to be part of. And where's that leading? Well, I've been quoted as saying that those last two aircraft will be our only remote piloted aircraft systems, because the next step in technology is increased levels of autonomy. We won't be piloting the next ones after Triton and Sky Guardian, and why do I think that's important? Because we've already earmarked the next project, and that was announced last year in the Force Structure Plan announcements, that we will have a future additional ISR capability project coming down the pipeline, $4 to $6 billion worth, exploring additional remotely piloted intelligence, surveillance, reconnaissance aircraft to increase the numbers and sophistication. The rule with ISR is you can never have enough. Once you're effectively flying and you've got high reliability, you can never have enough. And some of the ideas that are being scoped at the moment, we're still quite a few years away. Gate 0, that's our kickoff for a project, isn't scheduled for another 5 years yet. But some of the ideas that we're toying with here is ultra long endurance airplanes, like some of these photos, but also some more autonomous and aircraft that are able to be operated in a more contested environment. So reduced signatures being a highlight of some of those stealth fuselages that you can see there. We will consider all contemporary solutions to meet those requirements, and some of the exciting things that you'll have seen through Air Force's Jericho Disruption Unit and through the establishment of the space capability is that maybe some of this funding line will be spent on more disruptive or innovative applications like high altitude balloons, like cheap disposable rocketry, like low Earth orbit satellites, to contribute to that future additional ISR capability. But certainly from the UAS space, there is a bucket of money and certainly a funding line and intent there that we will be increasing our ISR capabilities through the use of UAS. So that's just around the corner. And while I might not get the opportunity to project manage or to define some of these capabilities, some of the more junior officers or other budding aerospace engineers within the Australian engineering ecosystem may well get to work on some of these really cool, exciting platforms. So on the topic of cool, exciting platforms, from an Aussie perspective, there's none that are much more exciting than this one, and that's because we did it ourselves, and that is certainly really exciting. So this activity, Defence Project 6014, $40 million at the moment invested, with another commitment for additional aircraft to be signed up and agreed in the very short future. But the first 40 million was about investing in 3 test and evaluation air vehicles. And that partnership is with the Boeing Air Power Teaming System. It is a fighter size and fighter sized aircraft. So the same kind of complementary ranges and speeds and performance to match and team with the rest of our air combat capability. Importantly, I think, like I said, as an Australian Defence Force officer, as an Aussie engineer, what's really exciting is about 80% of the development so far has occurred within an Australian content perspective, and about 70% of the actual airplane is designed, built, and produced here in Australia. And it's all tailored to our own country-specific requirements, and that's really cool. The point of the Loyal Wingman is to explore air teaming concepts and technology. It's the first step in air combat, air teaming concept exploration, and that's important as well. What we end up buying from a air combat, air teaming perspective may not be Loyal Wingman aircraft as you see them today in 2021, but it is a very exciting test bed for us to explore those concepts and technology. And we really need to do that because just around the corner is this huge project that's coming. Again, confirmed last year in the Force Structure Plan 20 announcement, $7 to $11 billion worth of future teaming air vehicles. we need to do some really good experimentation and some good test and evaluation to decide exactly what we want these airplanes to do in the future. How are they going to team with a wedgetail? How are they going to team with growlers? How are they going to team with JSFs? How are they going to team with the land environment, with the maritime domain? All of that needs to be teased out, and Loyal Wingman's a really good way to do that. We're not doing it on our own either, right? So the USAF's got a project, the US Navy's got a project, the Royal Air Force has got a project. There's a bunch of friends around the world that are exploring future teaming air vehicles or Loyal Wingmen at the moment. What does that mean? It means that what we end up acquiring might not look like a Loyal Wingman. We might not buy the Australian one. When it comes time to acquire, maybe the USAF one's the best, maybe the Royal Air Force one's the best. But we'll have learnt a lot, and I have no doubt at all that through our Five Eyes exchange community, we will have shared a lot of those learnings and will have contributed to the best aeroplane. And why, some of those particular things that we really use out is, how does a Loyal Wingman contribute to the evolution of air power roles? How might air combat, air strike change with uncrewed systems, with uncrewed aircraft that are maybe attritable or maybe expendable because of the price point that we can drive them down to? What does one pilot or one controller to many air vehicles looks like? We really need to tease that out, because right now our regulatory environment doesn't allow it. We can only do one-for-one control at the moment under standard regulatory approvals. So we need to tease that out. We need to know what's the technology required to enable it, and how are we going to make it work, and what are the skill sets of the people that are going to be able to make it work. And it's rapidly evolving technology. We know that. Short sprint cycles for ARPAS and UAS technologies. We're not great at rapid replacement of design or rapid evolution of design, and we don't do rapid procurement very well. And these could be complicated procurements. We could be flying many configurations of the one airplane that kind of looks the same. And we need to figure out how policy and procedures and regulations are going to make that work. Pretty exciting. Air Force have small ones, and I won't stay too long on this, because a lot of this work in the Air Force security forces is very closely tied to Army's work. But certainly want to put it up on the slide that Air Force have a project going, a minor project, 222, that is acquiring the R70 Skyranger and the Black Hornet Nano UAS for those security force squadrons and for those ground security force missions. That's pretty exciting, and that project is running right now. We're also looking at UAS to contribute to other missions as well, like maintenance inspection. So a C-17 tail section is really high, and to do an inspection on the top of that prior to drones, you had to park it, roll out the scaffold, find yourself a couple of technicians that are qualified to work from heights, get all the safety gear, go up, use the Mark 1 eyeball or some handheld cameras, do the inspections, take it all down again, disestablish the framework, and then the aircraft can go back out on the line. Well, we can be a heck of a lot safer and a heck of a lot faster by using a drone to do exactly the same thing. And 36 Squadron up in Amberley were pioneers in this area, and we do have a concept in development at the moment to roll out a similar capability to all of our wide-body aircraft. Anywhere that those kind of inspections takes time or puts our people at risk, we want to engineer out that risk to our people. So that's a pretty exciting project. And I guess shout out to Evan Smith, who's on the line. He was the Senjo that did this. All right, so that's what we're doing in Air Force at the moment. We've got some other experimentations going along out of Jericho Disruption, but they're the projects that we're doing. So I'll move now to Army. Like I said, we've got some platforms that are pretty old as well. So the RQ-7B Shadow 200 was the first UAS properly brought into service with the Australian Defence Force in 2011. So it was a full decade ago now. 2 systems, and it has proven to be a hell of a workhorse, right? It's an amazing airplane for doing what it does in the desert. and providing those tactical effects. But it is very much 10 years old already. It is already under an obsolescence management program. And while we continue to expand the capability scope of this airplane, it does need replacement. We're running a project right now, Land 129 Phase 3, with those submissions for the final 2 competitors going up to government shortly. And that's the Gate 2 decision there that you see at the end of 2021. In the run-up to that, we did a bunch of experimentation because we wanted to learn, just like we're doing with Lower Wingman, we want to learn about those deficiencies or those new things, new technologies, new enhancements that we really wanted to make sure we knew exactly what we wanted to buy. So we tested quieter airplanes, vertical takeoff airplanes, fixed wing that didn't require a runway. How do we support amphibious ops? What do modern sensors look like? How do we do a concept of operations where we can operate in rain or in a cloudy environment? So we learned all of those things through an experimentation program. There's a photo there of a Sheeble S100 where we did some partnering with Navy, learned a bunch of lessons, went out to tender. It was a really exciting competitive tender. It was not a one-horse race, and it's very exciting to get to this point now where 2 platforms are being pitched to government, and both of them will be a complete evolution on the Shadow, and really good for the Australian Army. So I'm really excited to see that one coming downrange later this year. We've also got a program going for a battle group capability. We call this the small plus capability. So something that's still small, you can still pack it down inside a car, but the plus is about the fact that it is got extra batteries and a bit of extra lift to give it 2 hours or more endurance, 20 kilometers or more worth of distance, and able to support a battle group commander. Why is 20 kilometers important? Well, a battle group commander gets guns, artillery, and artillery can shoot 30 kilometers. So that battle group commander really needs to know their area of operations out to the range of the guns that they've got. So that's the kind of capability that we've been looking to fill here. The project's been running, and we ran a successful competition. The result of that competition hasn't been announced yet, but interestingly, last year we have a formal program of record now announced for this kind of capability. That's Project Land 129 Phase 6. That'll be coming along in the back half of this decade. So these competing platforms right now, they really are a minor capability. They're a stopgap while we wait for the big program money to come down the line at the back end of this decade. Now, in the meantime, the one in the middle there, the Puma, we've actually been using. We bought an operationally urgent capability a couple of years ago, and we've got a handful of these systems. And I'm going to show you a quick video to contextualize Shadow and Puma, because we deployed both to Operation APEC Assist a couple of years ago. And this is a great little video just highlighting the fact that we can do this in the near region, and that we can do it in a fused and civilian airspace context.
Primarily, we'll be supporting the situational awareness for the government of PNG with the use of the Shadow UAV. Additionally, we've brought the Puma UAV, and it's seen its first service with the Australian Defence Force during this operation. It's pretty exciting going from training to execution. It's a great capability that we hope to continue to employ within the ADF. Not only are we're providing support and situational awareness for the ADF contingent, but we're doing so in a structured framework that is in accordance with PNG rule of law.
And those operations were conducted within just a few kilometres of Port Moresby Airport, with civilian traffic fully deconflicted. So that's just gives you an idea about just how good these systems are and how we can contribute to the local environment, the local region. Small UAS. So the WASP is our small UAS in service with the Australian Defence Force at the moment. It was acquired from 2018 under Land 129 Phase 4 Alpha. And this system is now in every combat team. So every squadron company, so 100 combat soldiers in the Australian Army, every single one of them has this capability. 45 minutes, 5Ks, day or night. A combat team has the ability to influence about 5 kilometers worth of battle space. So this is the capability that they get. Fully rolled out, fully in service, and like I said, fast technology cycles. We've already kicked off the replacement program for this Land 129 Phase for Bravo, which has started its tendering activity this year with some great industry engagement and an RFI and intent to register activity out there at the moment. I've just got a short video from some of the soldiers that use this to give you some context about the Wasp.
Okay. The Wasp Small Unmanned Aerial System gives the combat team commander his own dedicated intelligence, surveillance and reconnaissance asset never seen or held before within ADF. It's capable of flight out to 5 kilometres for 50 minutes. It's day-night capable and can be launched and recovered in all terrains and weathers. The Wasp can answer the commander's critical information requirements through full motion video or stills. We can either send digitally to him or verbally relay over communications.
So it's a super cool little aeroplane. It's been deployed all over Australia, and quite an amazing aeroplane. It's fully waterproof, so so it supports all of our boat and amphibious forces as well. And then right down at the smallest end, we've got our Nano, the Black Hornet 3. I already quickly referred to this one in the Air Force slides. They've now got half a dozen systems of this aeroplane as well. But we've rolled this out to every combat platoon or surveillance and reconnaissance team in the Australian Army. So a platoon is about 30 soldiers. 30 soldiers has the ability to influence 2 to 5 kilometers worth of battle space. So we give them a system that gives them 2.5 kilometers worth of range. In that pack up that you can see there's 3 aircraft in a kit. So the operator has the ability to send an aircraft out. Sure, it comes back 25 to 30 minutes later, but he or she's got another airplane that can send straight out again. And super quiet, very covert. I'll let the soldiers tell you about it though.
The Black Hornet Nano Unmanned Aerial System is a system that we're rolling out to combat platoons across the Australian Army. It's game-changing technology. It provides robotics down to the platoon level or down to the section level. And what it means is that soldiers are removed from danger. We don't have to send soldiers down into an intersection or over a hill to have that first look and see whether the enemy is there. We can send a robotic avatar to do that for them. It increases their force protection and keeps soldiers safer. The Australian Army is the first army in the world to proliferate this kind of nano robotic technology out into the conventional army. The Black Hornet program is very exciting. The Australian Army's been talking about taking advantage of robotic technology and enhancing our army and making it the most combat effective army that it can be for a long time. This kind of technology is a big component of how we do that.
So now that we have drones, we have the ability to get an eye in the sky before we commit any troops to going into that dangerous area, and that gives us also the ability to have a greater situational picture for commanders to make decisions. Although it only weighs 33 grams, we can fly it out to 2 kilometres and it can stay airborne for up to 20 to 25 minutes. It gives us plenty of time to achieve the mission. The defile appears to be clear, no signs of enemy movement, suggest amber movement through.
It's a special part of being a smart army. Smart young soldiers are able to really grip up this equipment quickly, find new uses for it, and enhance what we've done. We're expecting it'll be a big payoff on the investment in the long run.
So that is a super exciting capability. The soldiers love flying it. It is truly game-changing for them. So a pair of soldiers now has the ability to go scout out 2 kilometers with a fused infrared camera, detect the heat signatures of enemy armored vehicles, and then to the accuracy of 10 grid figures, be able to call in a joint fire strike on that. This Australian Army soldier has never had that kind of technology in their hands before, and it's super exciting. And how do we pick the best operators? Well, we stick a platform like this in their hands before we put them onto the military equipment. We identified a couple of years ago that we really wanted to make a drone literate army, that we wanted everybody to not be scared of the technology, and we wanted them to know about a ground control station, an airplane, a data link, and how to use cameras and what they're good for. So we rolled out the best commercial off-the-shelf platform that we could find at the time, the DJI Phantom 4 Pro Plus, and we rolled that training and the equipment out to the entire Army. And I'm not joking about that. I'm talking about cadets, all the reserve units, all the regular forces, everyone from the catering company and the band, all the way up to the infantry and the armored squadrons. And it's great, right? Everybody knows about this. Now, this is why one of the reasons we can say we've got more than 1,000 operators in the Australian Army, because a lot of people have done this training. And now we've got an experimentation tool. So without using really expensive high-end gear, we can give soldiers this kind of gear. They can go out, they can experiment with their tactics, technique, and procedures and learn how drones can help them and do things better, which means that when we buy the next generation of military specification gear, we already know those lessons. We already know how it's going to be used. So a really successful program. We've also been experimenting with logistics, uncrewed aerial systems in the Army. The one on the left there is a system designed out of Bankstown Airport by AMSL Aero under a Defence Innovation Hub co-funded contract. It's designed to lift 500 to 600 kilos worth of combat supplies, fly it into a landing zone, and then when it's emptied out, be able to fit 2 wounded soldiers in it and do a really quick extraction. So why would you use a $30 million helicopter with 4 or more people on board when you can do it in an uncrewed fashion? It's way faster, way less risky, and really exciting capability to be developing there here in Australia. The one on the right is a cardboard disposable small delivery device. So if we want to punch repair parts, blood products, other first aid supplies, rations, water purification, small quantities all over the battlefield, or we can do it cheap and quick and disposable with a cardboard disposable airplane. This one's designed and prototyped out of SIPAC Systems down in Melbourne. So we're doing a lot of understanding these new roles and what they'll do to the Australian Army, because we've had a really exciting decade of bringing into service those ones that I've already been through, but we need to plot out what's next. And the Army team over in Army headquarters have just kicked off a project for the Army Future UAS concept, a big activity, literally just kicked off a couple of weeks ago, partnering with industry, looking at Australian industry capability contributions and what those next future missions are going to look like for our land forces. So watch this space. If you want to see the video that these stills are grabbed from, jump onto LinkedIn, onto mine or Rod Lang or Drew McKinnon's account. It's a pretty specky little video showing some of the things that Army is thinking. And I also said that we do things for fun as well. And Sasha mentioned that we do drone racing. Here's just a quick grab of some of the cool places we've drone raced before. It's a bit old, but it's cool footage. But nobody else gets to drone race.
From the 18th to 20th of October, Australia will be in racing tournament. Looking forward to competing in a friendly and professional manner, but my money's on the Australians to win.
No other aircraft's ever going to do a power loop off the ski jump of our LHDs than a drone racing aircraft, which is pretty cool. And Jack was absolutely right. The Australian Army drone racing team clean swept that competition and won every category. So why do we do it, right? Not every kid today wants to join the Defence Force and play rugby or play soccer or cricket. We've got really exciting STEM kids coming into the Defence Force these days that want a war game, they want a drone race, they want a white hack, they want a cyber sport, they want an e-sport. So we've got new clubs, evolving clubs, but what I most like about this club is it's not just about supporting the soldiers, it's about supporting where ADF wants to go in the future. We need kids that can build drones with informal training that can apply commercial technology into new military contexts. And we want kids, soldiers and aviators that can have a discussion at a science festival, at an air show with the next generation and say, this is some of the cool stuff we've done. This is how we're contributing to capability development. And we're playing sport and having fun as well. And some of our soldiers have gone international to compete at drone racing events, and that's seriously cool. But here's just a recap of that event that the first video was advertising.
We're here at the Military International Drone Racing Tournament. A whole bunch of different countries have come together to do the first ever international military drone race.
We fly the drones in what we call first-person view, which means there's a live camera on board which is beamed directly into your goggles, so it's as if you're inside of it. So it can be quite exciting as you're flying around the track at up to kind of 90 miles an hour.
We build all our own drones ourselves. We select the components, then we solder them all together. We program them through a bunch of different applications on the computer. We actually go through that whole process as well to make sure it flies how we want it to fly.
Drone racers are STEMers. They are interested in science, technology, engineering and maths. They teach themselves how to build drones, how to code, how to solder. They teach themselves aerodynamics and electronics. And they're the kind of kids we want to have a conversation with about maybe considering joining the Australian Defence Force as a career.
The Kiwis are doing it, the Brits are doing it, the Americans have got teams. We had Thais and Malays, Dutch. We've got lots of people doing drone racing. So that's pretty cool. One slide on Navy. I'm sorry, I really need to get some cool videos from Navy because they've got some cool stuff going on. They've got two different types of fleets at the moment. Scan Eagle on the left, Shibble in the center there. Flights at sea, flights on islands. They're doing a lot of really great work, working up that arrow towards the mature, enduring solution to be delivered under C129 Phase 5. Which is a very exciting project that's been directed to have a high level of Australian industry capability, working forward into the future with Navy's remote autonomous systems and AI strategy. Really cool what's going on in Nowra with their aeroplanes and where they're flying them from shore and watching that unit evolve. It's been a really cool path. They've also now got a drone racing team. So we now do tri-service drone racing here in Australia, and we've got a couple of cadet teams as well. Army and Air Force cadets are all competing. So that's all pretty exciting. Hey, so I've given you a quick recap on everything that we've done in the last 10 years. Prior to that, it was a little bit science fiction, but the last 10 years have been really exciting. Drones everywhere in the Australian Army, drones going everywhere in Navy and Air Force, all over Australia and international. It's super exciting, and I've given you a bit of an insight into some of those new projects that are coming that are going to deliver. Some of them will be delivering next year, all the way out into the 2030s that get us all the way to 2040 and thinking about some of that autonomy that is coming down the pipeline. I really want to re-emphasize that Australia is a world leader in the tech, and that's why I've got a couple of bits in there about some of the innovation projects and some of the collaborations that we've got going on. Just watch the social media for UAS innovation. There's lots going on, and there's lots of prototyping that's going to be finishing up in the next couple of months. and then cycling into the next one. So that's really cool. And the ADF, you should all be proud that the Australian Defence Force is a world leader in UAS adoption and driving that into future concepts. We really want uncrewed systems, robotic and autonomous systems to be a big part of the Australian Defence Force in the future, because we got a lot of land and a lot of sea and a lot of air, and we don't have enough people to do all of that with crewed platforms. So autonomy and uncrewed is a big part of our future. And like I said, if you sum up all the projects that are in the IIP and the Force Structure Plan at the moment, there's $30 billion worth of investment that's going to go on in the Australian Defence Force out into the 2030s. So that's me. If you want to get in touch with me, do it through LinkedIn. If you want to keep a finger on the pulse of stuff that ADF is doing in UAS, follow my Twitter account. And if you want to have just an occasional burst of some really fun stuff going on, some really creative videos, things that never get done anywhere else, follow the ADF drone racing sites on Facebook and Twitter. You know, we're the only people that fly drones through an artillery barrage in support of 30mm chain guns from our armored vehicles on a firing point and flying literally down the firing lines. There's some really great footage out there that'll make you smile and make you pretty proud of what the young people of the Australian Defence Force are doing. I'm happy to take questions, Sasha.
Hi, Kieran. Thank you so much. I've got quite a few comments saying how good your talk is. So thanks again. So what I'll be doing is I'm going to start the questions with the question that came earlier and just work our way down. Sure. So Juliet was asking, can a Triton be refueled in flight?
No, it can't. But we don't necessarily need it to. When you've got an aeroplane that does 24 hours in a standard slit skin sortie, you don't really need it. We've got enough airplanes coming that we can maintain our area of interest with 3 aircraft to do a permanent on station when they fly for 24 hours. One of the things we're not doing at the moment is following a path of, people have probably seen the MQ-25 Stingray being prototyped out of the US Navy, and it's doing aerial refueling of Super Hornets, of itself, and of JSFs, but that's not somewhere that we've gone just yet. But it might be in our future.
Right. Kebal is asking, do you see a joint operational command within the ADF for command and control of all UAS capabilities?
I'm sorry, can you say that one again? It glitched a little, Sasha.
Yeah. Do you see a joint operational command within the ADF for command and control of all the UAS capabilities?
So that's a bit of a tricky question without getting specific. And the reason I say that it's a little tricky is because all of our operational commands are joint already. The Australian Defence Force never goes on an operation these days as just the Army or just the Air Force or just the Navy. It's always joint. So the way that we do domestic training, raise, train and sustain of our forces is we assign them out to one of those domains: Army, Navy, Air Force, space and cyber. And one of those domains has the responsibility for training the aeroplane and the people that fly it. But then when we deploy it on operations, we always deploy it into a joint command and control organization. And that's why whenever you see the ADF deploying, the name of that organization is always JTF and a number. JTF 633 is the contribution to Afghanistan for the last 20 years. It's always a joint task force. We always see to them as a joint asset.
Right. Another one from Julian. Will swarm technology be considered in teaming AVs?
Absolutely. Why wouldn't we? Right. So, one of the things I talked about on the lower wingman slide is what does one-to-many control look like? but definitions are important, right? So a swarm is just many aircraft flying at once, and that could be 10 aircraft flown by 10 operators. That is still a swarm. 10 aircraft flown by one operator, but they're doing one-to-many control is swarm. But what I think your question means, and that's because people like to think in the science fiction realm and what's in the future, is whether we're going to get after robotic swarming and robotic swarming behaviors where the aircraft decide to do what they want. We direct them to go do a mission, but they decide how they're going to do it. Yes, we're looking at that as well. And we've got really great experimentation programs going on in defence science technology and in Australian industry about what swarming and what robotic swarming technology and algorithms look like for future aircraft. And the Australian Defence Force is absolutely interested in those, and we will be pursuing those in some of our future projects. But we're not doing it just yet. The technology is not quite mature enough just yet.
All right. Now, question from Nicola. Each of the UAS presented are based on meeting a capability need, but also mentioned the distribution numbers, e.g. one for every 30 or 100 soldiers. Do you have an ideal ratio in mind that fits with the one-to-many idea?
No. So the way we have done those calculations so far is effects-based capability development. So, a platoon of 30 soldiers, one of the things I mentioned, has a combat sphere of influence of 2 to 5 kilometers. It's the area of operations that defines the type of aircraft that we buy for them, not the fact that 30 people do it. So I might have confused those calculations a little, but I have found in the past it's helpful to let people know in that size of area of operations about how many soldiers there are. But we do all of our capability development these days based on effects. What is the effect we want generated? And then we work back from that as to what bits of technology and what quantities of those technologies we acquire, and then how many soldiers and officers it takes to run it. It's all worked back from an effects perspective.
Question to Ryan, who unfortunately isn't with us right now. Given the amount of investment in UAS and unmanned systems at large, do you anticipate that Australian universities will begin offering specific drone literacy programs, such as bachelor's in engineering in unmanned systems, master in unmanned aeronautical systems, something in those terms?
Look, I think they already are. When I went and did my engineering degree, you only got to do the foundation engineering degrees, right? But these days, there's already hybrid and evolved engineering degrees, like a mechatronics degree, like an avionics degree, that are already taking bits and pieces of the traditional foundation degrees and turning them into degrees that are more relevant in some industry fields. And certainly when I look across the workforce, my engineering workforce on the Triton and the Sky Guardian program, I have a full spectrum of university degrees already contributing to my 30 people in our engineering and technical workforce. The core degrees, as well as mechatronics, as well as software engineering, as well as avionics. So I think the universities are already identifying that that this is needed. What I think will be even more interesting is whether some of these universities take the next step, a bolder step about hybrid learning. And by that, I mean, it's great that university, let's use the example of University of Sydney, right? University of Sydney's aerospace engineering course goes and builds a light aircraft every year, or every 2 years. And they get their students hands-on aircraft manufacture experience and production experience through that. Well, maybe the next evolution is you ditch that, which is really expensive and it has a huge overhead, and you teach every one of your students, you know, in first year, you're given a bucket with all the components for a drone racing aircraft. And every student learns not just the aircraft structures and traditional avionics stuff that goes into a light aircraft. They get that because you can design and build your own composite structures for drone racing. You can select and choose your electronic components, but it also teaches you soldering and electric motor theory and data links and comms links and video production and all these other skills that I think can maybe really enhance the kind of people that we're looking towards getting at the back end, which is faster design evolution and cheaper. Let's be honest, in the case of unmanned uncrewed aerial systems. The other thing that I think is really interesting as well is how drone racing pilots can learn a hell of a lot of aerospace theory off YouTube. They don't go to uni to learn these things. They don't go to uni to learn how to design and build their drones or solder them or code them or do any of that work. They go onto YouTube sites and they watch videos, and they go down to their drone racing club on a weekend and they do, father to son, mentor or mentee type teaching in the field. They don't go to TAFE and they don't go to uni, but there's some of these kids that have never gone to uni and never gone to TAFE that I'd take into my engineering team tomorrow because they've got the skills, they're self-taught skills. And I think that is the bold end of where universities might want to be thinking about how uncrewed technology, autonomous technology, open source development of technology could be scoping where they shape their degrees, because you don't necessarily have to do 4 years of very formal teaching anymore to get the smarts upstairs about how to build an airplane in the future. That's what I think could be really interesting for our university community to consider.
Right, and just a follow-up question from Alexander. He said, I'm currently going through the Air Force graduate entry and like to know what RAF base would be the best to be assigned to if he wants to work at the UAS platforms.
Edinburgh, absolutely. So, I mean, Triton and Sky Guardian are both going to Edinburgh at the moment. And, all of our Loyal Wingman test campaign so far has been flown out of Woomera, which is, just down the road from Edinburgh. So that's where I'd be shooting if I was a young pilot officer or flying officer engineer coming in and wanting to do uncrewed technology stuff.
Okay, Michael is asking, how's the Australian military supporting and encouraging local Australian defense industries and universities to get into niche drone technologies?
Okay, so that's a really big question because we're doing a lot, right? So, so what's needed to do that encouragement and strategic thinking is a strategic plan, and the Australian Defence Force identified that a long time ago, and in 2004, and then they did an update in 2007. They published. With industry, it was a science, defence, and industry collaborative document, a document that was called the Adf Uas Roadmap, and that roadmap spelled out the path for the next 15 years. So it was meant to run to 2020, and in that roadmap, it plotted out combat team UAS, brigade UAS, Predators, Global Hawks, and something for the Navy. And all of that was in the strategic plan. As each one of those projects kicked off, each one of those projects studied what was available in Australian industry and weighed up the relative risk versus investment profile. And so far, every one of them bought a product from offshore. But in parallel, a conversation was had on every single project about what could Australian industry do if it had the right level of maturity and had the right level of investment. And a really great case study is in the combat team UAV, the one that the project that bought the Wasp. When that went to decision, it was shown that in the early in the decision-making cycle, we could have built our own if we wanted to. And what they did was they cut a slice of funding aside and they pushed it into Army, and they said, Army, go and seed industry. So when the Wasp starts to run out of life of type, when it starts to become obsolescent, we want Australian industry to compete this. And over the last couple of years, 11 development contracts, more than $10 million has been tipped into small UAS technology through the Defence Innovation Hub. And we are absolutely expecting that Australian industry will compete that one. That'll be the first that'll see a genuine Australian competition, I think. And then the plan is to expand out of that. And why I'm confident in saying that is because the Australian Army is rewriting their UAS strategy right now, and I gave them a plug there on the slides. So they want to put their next 10 years worth of a strategy out there, so industry can start designing within our own sovereign capabilities towards it. Within Air Force, we've done the same. Triton and Sky Guardian are both American off the shelf at the moment, but we've already decided that under the additional ISR program, we want a much higher percentage or contribution from Australian technology. And we just ran a Australian industry capability environment scan workshop only 2 weeks ago that brought together 170 representatives from industry and from the universities, brought them together for a workshop to start that planning. So I think that's the answer. We have been doing it, but it hasn't been a good enough investment for us, weighed up against risk. But what we recognise now is that Australian industry is at a maturity level where we want to give them more innovation challenges, more technology challenges, and we want to see Australian industry genuinely compete for the future projects.
Right. Different question this time, Peter, from Peter. The US Navy and Marine Corps are going to be deploying the new Martian UAV, VBAT, from Australia from late this year. Will the ADF be seeking access to this system, given both US services are in early stage acquisition?
No. We did have a look at the VBAT early in the Shadow replacement program, and it did not meet the Australian requirements set, and was not evaluated any further after that. It's good to see US Marine Corps and US Army looking at it. It is a very mature aircraft for what it was designed for. But we, when we did our market survey for Land 129 Phase 3, it did not meet the threshold for pursuing further.
Right. Teddy is asking, are we going to jump onto the Hypersonic UAV project with the US Air Force?
Maybe. But decisions out on that. So we've only just kicked off our Hypersonics program in the Australian Air Force. It was only announced that we're going to have one last year, and it's still in initial scoping. I think it's too early to say whether that will be a thing or not. But good question, Teddy.
I'll do another couple of questions because it's getting quite late. One from Glenn. Will either the Triton or Sky Guardian platforms have a flight data recorder on board for accident investigation purposes, or will we be reliant on tracking data from the ground control station?
Both systems have flight data recorders.
Right. Nimish is asking, do you see cybersecurity as a primary requirement in the UAS teams?
Absolutely. Cyber is one of the biggest vulnerabilities of uncrewed aerial systems. And that's because you don't have everything inside the can, right? So we've got an airplane flying maybe on the other side of the world. Its flight control system then gets bounced through a satellite down to a terrestrial ground station, then runs through a terrestrial fiber optic network into our base at Edinburgh, and then has to transition into a concrete building, into our own ICT networks. So there's a lot of places there outside of the can where we could be potentially vulnerable. And that's why right from the beginning of our projects, we have a cyber worthiness and a cyber vulnerability program where we engineer everything that you would expect from a military specification airplane to the same levels into our cyber assurance plan.
Right, and we'll try to squeeze a couple more quick questions. Catherine is asking, what opportunities, pathways are available to people wanting to work closely with ADF on these and similar projects, but can't join the ADF per se?
Oh, there's heaps. Look, so the Australian Defence Force is obviously the user, and you have to join up in uniform to use the UAS, but all of our acquisition and sustainment activities are executed by the Capability Acquisition Sustainment Group, which is half Australian Public Service, and there is a significant engineering and technical workforce in there. When we don't have enough uniforms and APS or the right skill sets, we contract those in through our major service providers. So contractors are able to contribute. All of our sustainment these days is done under a platform stewardship program. So, the Triton, for example, which is manufactured by Northrop Grumman, we have a partnership with Northrop Grumman Australia for managing that fleet through its life. So you can get in through there. Any one of those companies that is working within our innovation network at the moment, and there is many more than two hands worth of companies that are running active UAS innovation projects at the moment. You can work for any of them. Defence Science and Technology Group, which is taking care of our early stage research for UAS technology. That is a civilian organisation that can employ as well. There are so many opportunities as a civilian to work in defence UAS. There's heaps.
All right, and I think we're gonna have one last question from Andrew. Is ADF looking into acquiring high-performance unmanned aerial targets to prepare against the future advanced threats?
So we already have uncrewed aerial targets, and one of Australia's first forays, globally successful forays into that technology was the Jindovic target drone. Like I said, we are world leaders, and we pioneered that project 70 years ago. We've been leading that kind of technology. We already have the latest generation of uncrewed aerial targets, and there are conversations already running around about what do UCAVs do in a contribution as Red Force as we exercise and train our people. So I think that the short answer is yes. The long answer is a 70-year-old history lesson, and then some really great future scoping.
All right, thank you. Thanks everyone for joining. We're going to wrap up after this. Thank you, Kieran, for a lovely presentation. And everyone, our next presentation is on October the 7th from Professor William Schneider from University of Missouri, who will be talking about space debris. We'll send all the details out very shortly. Thanks again, Kieran, and have a good night, everyone.